This is the first of two videos about balancing equations. A chemical equation is essentially just something that just summarises what happens in a chemical reaction. So here's a chemical reaction. It's hydrogen reacting with oxygen to make water, and to balance it we have to have a 2 there and a 2 there. So balancing equations is about having the same number and type of atoms on the left of the arrow, that's the pivot point in this reaction, the balancing point if you like, the same number and type of atoms on the left of the arrow as we have on the right of the arrow. For example, here I've got 4 hydrogens on the left and I've got 4 hydrogens on the right, so we must have the same number and type of atoms on the left and right of the arrow. So this video is about counting atoms, because before we can balance to have the same number and type of atoms on the left and the right of the arrow, we have to be able to count atoms accurately. Now, a lot of students who can't balance equations, the simple reason is they can't count atoms. So this video is quite straightforward, really, but it is essential. So we've got all the rules here in this box. You can read those in your books anytime you want. This video, all we're going to do is just talk through the answers to the questions beneath, and this will explain the rules as we go. First off, element symbols. Let's just make sure we understand those totally. Okay, so I've got a periodic table here, and let's just take I don't know, element 59 here, for example, cobalt. Sorry, element 27, I should say. 59 mass number, element number is 27, cobalt. So let's just take cobalt element 27 here, for example. Cobalt has got the symbol CO. Now, like every element, the first letter of the symbol is a capital. Now, some elements have one letter, for example, element number 6, carbon. Carbon, the element is C, capital C. Every element starts with a capital, and that one's just one letter. This one happens to be 2 letters. So the second letter is always lowercase. Now, that's really, really important. A lot of students get questions wrong in chemistry for the simple reason they write the second letter as a capital, and that would confuse things massively. Let's explain why. For example, that element there, cobalt, was that one, CO, capital C, little o. If you happen to write it like this, capital C, capital O, then any chemist looking at that would think that's carbon monoxide, because oxygen has the symbol capital O. So every time we have a new capital, we have a new element in a symbol. That's really, really important. Because if we look at this example here, carbon dioxide, count the number of atoms in carbon dioxide. The first thing to say is chemists never write the number 1. So after every element in a formula, there is always a number, but you may not see one. If you don't see one, that number is 1. It would be much easier if this was written like this, wouldn't it? C1O2. Chemists never do that because they said that, their logic is they've written C, so there must be at least one of them present. So there's no need to write that number 1, because if there wasn't one, we wouldn't write C. Having said that, if there's more than one, they always put the number. So there's always a number there. If you can't see it, it's a number 1. So that's C1O2. So what we have here in carbon dioxide, there's carbon times 1, and oxygen times 2. There's 1 carbon and 2 oxygens in carbon dioxide. Next one, same logic, H2O. So that really should be written H2O1. So 2 times hydrogen and 1 times oxygen. Some students will tell me there's 2 oxygens because they think that 2 there goes with that oxygen, but it doesn't, because there's no number after the oxygen, so there is a 1 there. Okay, the number always comes after the element. Next one down here, 2 carbon dioxides. Okay, so now we've got a big number in front of it. Now in a chemical equation, like this one up here, these big numbers are called stoichiometry numbers. Stoichiometry is essentially the ratio of numbers of molecules of one reactant that react with another. The little numbers never change. The little numbers are formulae numbers, and we must always get those right, otherwise the equation will always be wrong. And the formulae numbers never ever change. These big numbers here can change to get the balancing, and we'll look at that in the next video. Okay, so the big numbers talk about the numbers of molecules that are present. So 1 carbon dioxide looks like this. It's got a carbon bonded to oxygen and carbon bonded to oxygen. So we did that in question number 1, CO2, 1 carbon and 2 oxygens. And it looks like that. And that's 1 molecule of carbon dioxide. Now, if we have a big number 2 before it, there, okay, that means we don't have 1 molecule of carbon dioxide, we have 2 molecules of carbon dioxide. So essentially what we have to do if we've got a big number before it is multiply everything after it by that big number. So this was C1O2, but we've got 2 carbon dioxides. So it's 2 times 1 carbons. So in other words, 2 carbons. 2 times carbons, and 2 times 2 is 4 oxygens. 4 times oxygens. And hopefully you can see that if you look at these pictures at the bottom. I've got 1, 2 carbons, that's why I've got 2 carbons. I've got 1, 2, 3, 4 oxygens, 4 oxygens. Right, next page. So same logic, 4 carbon dioxides, 4C1, so that's going to be 4 times carbon. 4 times O2, 4 times 2 is 8 oxygens, and 8 times oxygen. Now here we've got 2 carbon dioxides and a water. Okay, so the carbons, 2 times C1, that's fairly straightforward, 2 times carbon again. Now oxygen, 2 times O2, so 2 times 2 is 4 oxygens. Now don't write 4 oxygens because we also need to look at this product or reactant in this, as it could be, but I'm thinking to myself, these are the products of the reaction when a hydrocarbon burns with the water, which is why I say product. So let's look at the oxygen again. So 2 times 2 is 4 oxygens, plus we've got an oxygen over here. Now there's no number before the water, so of course there's a big number 1 there. Remember, if there's no number present, there's always a 1. So it's H2O1. So 1 times 1 oxygen there. So 1 oxygen there, plus those 2 times 2 is 4 oxygens there, 5 times oxygen. And then we've got 1 H2 as well, so 2 times hydrogen. Next one, 5 carbon dioxides and 4 waters. So 5 C1O2, 5 times carbon. 5 times O2, so 5 times 2 oxygens, plus 4 times O1, so 4 times 1 oxygen, so that's 4 oxygens there, and 5 times 2 is 10 oxygens there. 10 oxygens plus 4 oxygens is 14 oxygens. 14 times oxygen, plus 4 times H2, 4 times 2 is 8, and 8 times hydrogen. Next one, ammonium nitrate, a type of fertilizer, ammonium nitrate. So here we've got NH4NO3. So that's written N1H4, N1O3. Okay, so many students get these things wrong because they don't realise the 1 follows the elements without a number. So we've got a nitrogen there and a nitrogen there. Okay, so that's actually going to be 2 times nitrogens, 2 times nitrogens. H4, 4 times hydrogens. O3, 3 times oxygens. Next one. Right, we're now getting down to brackets. We have brackets when we have a more complex anion, like a hydroxide or a sulfate or a nitrate. A more complex anion is a species that's made up of more than one type of element. Okay. When we have brackets, everything inside the brackets is then multiplied by the number outside the brackets. For example, so we've got, let's write it a little bit bigger. Cobalt hydroxide. Okay, so this really should be written cobalt 1, oxygen 1, hydrogen 1, but everything inside the brackets is multiplied by the number outside, so 2. So this really is then cobalt 1, oxygen 1 times 2, 2 oxygens, hydrogen 1 times 2, so 2 hydrogens. So let's write that down up here again. Cobalt 1, because there's no number after the cobalt, cobalt times 1. Oxygen, 1 times 2, so 2 oxygens, oxygen times 2. And we've got hydrogen, 1 times 2, and so that's hydrogen times 2 as well. Next one, another set of brackets this time. Al2, so that's an easy, straightforward aluminium. Aluminium times 2. Now we've got the brackets. This time the brackets, we've got a sulfate ion. So I've got capital S with no number after it, so there's a 1. But there's a 3 outside the brackets, so that's 1 times 3, so 3. Sulfur times 3. So sulfur times 3. The oxygen now, O4 in the brackets, but it's 3 outside the brackets, so it's 4 times 3. So oxygen times 12, because there's 4 in the brackets, multiply the 3 outside the brackets, 3 4s are 12. And the last one, we've got ethanol here, alcohol. Remember the alcohol family that happens to be called ethanol, we call it commonly alcohol. This is ethanol. So what we've got C2H5OH. Now the difficulty here often is the hydrogen appears in 2 different places, so we need to rationalise that. So we could write that C2H5, and that one there is 6H6, H6O, and that might be a little bit easier. Okay, so let's go through it now. 4 times 2 carbons is 8 carbons, 8 times carbon. Okay, 4 times 5 hydrogens is 20, plus 4 times those 1 hydrogens is 4, 20 and 4 is 24, or if you'd written it like this, it's possibly easier, 4 times 6 hydrogens, 4 6s are 24. So that's going to be 24 times hydrogen. Oxygen. Okay, oxygen appears both in this molecule here and the oxygen over here as well. So I've got 4 oxygens there, 4O1. There's no number after the oxygen, so it's a 1. 4 times 1 oxygens there. Plus these oxygens over here, 12 times 2, 24. So that's 24 plus 4, 28. 28 times oxygen. Now if we can do all those, we can count atoms really very well, so we're now ready to start looking at balancing equations, and that'll be the next video.